We are going to kick off chapter 6 by talking about composite functions. So compositions use this little symbol that's like a circle. So it's f circle g of x. So this is still function notation. Or we could do f circle g of a number. So when we are working these composition problems, we work from right to left instead of left to right. So like if we have a number here, this number would go into the function g, and you would figure out the output, and then you would take that output and put it into the function f. So that's what this says right here. F of g of a is another way to say it. So f circle g of a, or f composed with g of a. We work the problem from right to left. So first find g of a. That's going to give you a number. And then second, plug that number into the function f. So here we have f of x is 3x plus 2. G of x is 2x squared minus 1. And we want to find f circle g of 4. So we're going to take 4 and put it into the function g. So I'm thinking g of 4 would be 2 times 4 squared minus 1, which is 2 times 16 minus 1. So 32 minus 1, 31. So when I put 4 into g, 31 was the output. Then I'm going to take that output of 31 and put it into the function f. So then I'm finding f of 31. F of x is 3x plus 2. So 3 times 31 plus 2, which would be 93 plus 2. So we got out 95, which makes that our ending answer. Okay, let's try some more. G circle f of 2. So again, we start from right to left. So 2 goes into f. So f of 2 would be 3 times 2 plus 2, because we're using that same f of x. So that is, 6 plus 2? So 8 comes out. So 2 goes into f of x, and the output is 8. We take that output of 8 and put it into g of x. So g of 8 would be 2x squared minus 1. So 2 times 8 squared minus 1, which would be 64 minus 1. That's 128, right? So 127 would be our final answer. Okay, what's next? F circle f of 3. Okay, so we can even do this like with the same one over and over, the same function. So again, same process. 3 goes into f, and we're going to see what comes out. So f of 3, we do 3 times 3 plus 2, which is 9 plus 2, so 11. So 3 goes into f. The output is 11. We take that output, put it into the function f again, so f of 11, which would be 3 times 11 plus 2, so 33 plus 2, which makes our ending answer 35. Okay, let's try a different function. Well, two different functions, f of x and g of x. So we've got 5 goes into g. G of x is 3 times x. So g of 5 would be 3 times 5, or 15. So the output is 15. That output goes straight into that next function, f. So f of 15 would be square root of 15 plus 1, or square root 16. So then that answer is 4. We don't need the plus or minus because the radical was already in the problem. Remember that when we put the radical in the problem, then we have to remember to include the plus minus. Okay, next one. 7 goes into F. The output goes into G. So 7 into F. So that would be square root of 7 plus 1. So square root of 8. Square root of 8 simplifies because 8 is 4 times 2. So we got 2 times 2 times another 2. That pair of 2's goes out. The single 2 stays in. So 2 square roots of 2. So our output is 2 square roots of 2. Then that is going to go into g of x. So g of 2 square roots of 2. G of x is 3x. So we have 3 times 2 square roots of 2, which makes 6 square roots of 2. So that would be our result. Okie doke. Next, F circle F of 9. So 9 goes into F. That output goes into F again. Yes, I want that color. Okay. So F of 9 will be square root of 9 plus 1. So square root of 10. Then that output, 9 goes into F, square root of 10 comes out and goes back into F. So F of square root of 10. So I have square root of 10 plus 1. Well, it ain't cute, but it's the answer. Square root of square root of 10 plus 1. Nothing we can do to simplify that. Okay, next. This is our last one, then we get to go to the next page here. Negative 2 goes into G. The output goes into F. Okay, so G of negative 2 would be 3 times negative 2, which is negative 6. And then F of negative 6 would be square root of negative 6 plus 1, which is square root of negative 5. And that is actually a non-real answer. So that wouldn't have a real answer. If they wanted an imaginary answer, we could give that to them. But for now, I think we'll just say it's not real. Speaking of non-real answers, when we see a function like f of x equals square root of x plus 1, we should already know that this is going to give us a domain restriction, because remember that our 2 times that we have to be careful about domain are when we have variables in the denominator and variables inside even indexed radicals. So for f of x, we should already be thinking about domain restrictions. And if you remember, when we have an even index radical, the way that we find domain is to set the radicand greater than or equal to 0. So we take what's inside the radical, set it greater than or equal to 0, because we can take the square root of 0, but we cannot take the square root of a negative number. So that's how we figure those out. Subtract 1 from both sides. We get x is greater than or equal to negative 1. So our domain for f of x would be from negative 1 to infinity. So when we look at trying to take negative 6 and put it into the function f of x, negative 6 is not in the domain of f of x. So we are not going to get a real answer because f of x has a restricted domain that does not include that input. We will definitely be looking at domain of composite functions as we get later in this section. There are a couple of other ways that we can evaluate these composite functions. So here's a table. Ignore this part for now. That shows our input values of the x values up on that top row, and then f of x and g of x in the next two rows. So what this means is like when x is 0, f of 0 would be 5. So that's how we read this table. G of 0 would be 1. So it's just giving us inputs and outputs instead of giving us function rules. But we're going to still evaluate these the same way that we were. So we're going to take our original input and we're going to move from right to left. So same way we started out doing these, 1 goes into G, and then whatever we get from the output of that is going to go into F. So G of 1, we can look up in the table. G of x, when x is 1, G of 1 is 0. So the output, when we put 1 into G, the output is 0. So we're going to take 0 and put it into F. So F of 0 would be 5. F of x for 0 would be 5. So this answer is 5. Okay, let's try another one. From right to left. So 2 goes into G. G of 2, according to the table, G of x at 2 is negative 3. So negative 3 came out, which means that negative 3 is going in to F. So F of negative 3. So F of x at negative 3 is 11. So that'll be our ending answer. One more. We're going to do F, circle F. So again, 3 goes into F. F of 3 is negative 1. That's our output. So we take that and put it into F. F of negative 1. F of negative 1 is 7. So that's our ending answer. All right. We can also do this same type of thing with graphs. So let's see how that's going to go. G of x, I'm just going to make G of x purple. And I'm going to make f of x brown, tan, whatever color this is, just so we can reference them by color. Okay. We're going to do the same thing that we've been doing. We're just going to use the graph to get our values. So I will start with the input of negative 1. Negative 1 is going to go into F. So I need F of negative 1. F of negative 1, so I'm looking for negative 1 on x and the value on f of x. I have an ordered pair negative 1, 1. So when the input's negative 1, the output is 1. That's the y value. So 1 comes out. And then I'm going to take that output and put it into g of x. So I need g of 1. So I go where x is 1, and I follow that up to g of x, and the output is 4. So g of 1 equals 4. So that's going to be the final answer, will be 4. B, negative 1 goes into g. Whatever I get out goes into f. So g of negative 1 is what I need first. When x is negative 1, g of x is up here at 3. So g of negative 1 is 3. Then that needs to go into f of x. So f of 3 would be, when x is 3, f of x is negative 1. So negative 1. That's how we end up. Okay. A couple more. 0 goes into f. That output goes into g. So I need f of 0. F of 0 is 0 because my ordered pair is 0, 0. And then 0 goes into g, so g of 0 is, when x is 0, g is 5. So g of 0 is 5. So that's where you end up. Last one. 4 goes into g, that output goes into f. So g of 4. When x is 4, it looks like g of x is 2. And then 2 is going to go into f, so f of 2 would be -2. So that's how we end up on that one. Now, remember that even if I didn't have these thick dots at each of these ordered pairs, those values would still exist. So they do not have to be labeled in order to have a function value. I just made them thicker dots so that we'd definitely be able to have a better estimate of what that value is going to be, and also so that I drew it accurately so we'd be able to answer these questions. I think what I'm going to do is stop here for now and pick up on page 3 next time.